Let's start it. This is my PPT, and before my presentation, I would like to run this program first because it takes significant time to run it. Okay. Okay. So we run it first, and then we see this presentation. Okay. Okay. My topic's face recognition based on the radio basis function neural networks, and we can see this topic in two parts. The face recognition is the problem, and the other part is the way to solve this problem. We use the radio basis function neural networks. And this is the outline of my presentation. First, I will illustrate the problem. Second, I will take a look how to solve that problem by using the RBF neural networks. And the third is performance, and then finally we draw a conclusion. What is the facial recognition? Well, here I provide a Wikipedia description of the problem. Facial recognition system is a computer application for automatically identifying or verifying a person from a digital image or a video frame from a video source. Well, this definition may be very long and hard to understand, because simply speaking, facial recognition is just to recognize a person by his or her face image automatically. This process is done by a computer automatically, not human beings. Well, here are two very famous presidents of the United States, and they are President Bush and President Obama, and human beings can easily recognize who is President Bush and who is President Obama. However, how computer to do it? How computer know who is who? So next, let's see how to solve that problem, because it is a pattern recognition problem. There is a branch of classifiers we can choose. They are Bayes classifier, RBF networks, and support vector machines, etc. And the prototype of this system is very simple. Suppose you have a classifier, you input facial image as input, and the output is who or she is. Very simple. Well, more detail is we need to a database, which means when we get the input of facial image, then we retrieval this database and report the most similar one as the result. It's not exactly same, but most similar. Well, let me show what is the RBF neural networks. Here is the official definition of RBF neural networks, and radio basis function network is the artificial neural networks uses radio basis function as activation functions, and the output of this network is a linear combination of radio basis functions of the input and the neuron parameters. This definition is very long and really hard to understand, and this picture is very simple to understand. Well, there are three layers, and this we call the input layer, and this we call the hidden layer, and this is the output layer. And for the input layer, normally speaking, how many features we have, how many input nodes we have, which means that this x1 is xd is the d-dimensional features here. And here is the output layer. Normally speaking, how many classes we have, how many output layers we have, which means each output represents a certain class. And here is the hidden layers. And the number of hidden neural in hidden layers is very complicated to choose, because if there is too many hidden layers, hidden nodes, well, this classifier will be overtraining, which is not good. Well, if there is too few hidden nodes, this classifier will be underfitting, which is also not good. So we have a medium value, which means we have an optimization value for this. But this is not the focus on this project. Well, here is the equation of the RBF neural networks, and this means the J's output is the linear combination, the W is the weight, the linear combination times R. R is Gaussian function defined by this. Okay, so this is a linear combination, and this is a Gaussian function applied on this hidden neurons. And this Ci and the sigma I is the parameters of a Gaussian function. Okay, so then let's just see how to train this this classifier. Well, first we need to update W. How to update W is this is just the vector style of these two equations. This is vector style. Okay. So by applying the LSC method, we have the W star equal to this one. This is the training rules, which this method called the pseudo inverse algorithm. This is demonstrated in very detail in my written report. This is then after updating the W, we need to see how to update the RBF parameters. And the two parameters of a radial basis function are ith cluster center Ci and the width sigma I. And we need to apply a back propagation algorithm, and which means we need to a target function. This is a target function. The target function is a mean square error, which means this is the target and this is the output. And the target minus output square and add them together, which is accumulation of error, and times 1 over 2. This 1 over 2 here is easy for we compute the derivative later on. And we compute the derivative and then apply the chain rules. We have this how to update this center. This is center, and by these rules, update this center. And the same thing, by applying the chain rules, we know how to apply how to update this sigma j. Okay, this part is very you can see the very detailed things in my written report. Let's get here. Let us see how the performance. First, we need to know how to measure that performance. Well, two things. One is precision, and the other is recall. What is precision? Precision is a fraction of the retrieval sample that are relevant, which means this is a relevant number of relevant sample. This is the number of irrelevant sample. Add they together. This is a number of samples retrieval. So this is the fraction of the retrieval sample that are relevant. Well, this is a recall. Recall means what? Means fraction of the relevant samples that are retrieval, which means this NR is the relevant sample you retrieval, and the NR prime is the total number of the relevant samples. So this is the recall. Very simple. You can think that if you go Google and you type something you want to search, and the Google give you 10 results, for example, and 5 of them is relevant, and so the precision of this case is 50%. For example, suppose that there is totally 20 relevant samples in the Google database, and in the first 10 results, 5 is relevant, so the recall this case is 25%. Okay, so this is the testing results. Here should be still not okay. Let us see later. This is a testing result. The testing result is very weird. That we do very well job on the later 20 classes, but very poor from the class 0 to class 20. Well, I double check many times that that my program is correct, but I don't know why this happened. And the recall is same. Better later, better these classes and poor these classes. Well, let's draw a conclusion that a radial basis function neural network is a well-known classifier in pattern recognition, and it's easy to understand and easy to implementation. Well, the result is very strange. Maybe some parameters of the RBF neural networks is not correct, but I'm not sure. But I'm pretty sure that my program correctly implements all of these things. Maybe I will improve next time. Thanks for watching. Thank you. Okay, and the last thing is, oh yeah, and the program result here, running very long time, and the result is the same as the result here. The result is same as the result here. Same thing. Okay, thanks for watching. Bye bye.